Next is paragraph type question for question number 51, 52 and 53. That is, it is given over here that each point P on the parabola y square equal to 4ax has the property that its distance from a fixed point S, that is a comma 0, is same as its distance from a fixed line x equal to minus a. This is a very general property of parabola. You all must be aware of this. So let us solve question number 51 first. It says that suppose a variable point P moves such that its distance from the point minus 1 comma 7 by 3 is same as its distance from the line 2x plus 3y equal to 5. Then P does not trace. Now most of the students must have attempted this question wrong, right? Now here the important crux of this question was that the point that has been given, that is minus 1 comma 7 by 3, is lying itself on the line. It is satisfying the line. Let us say this is the line L1, that is 2x plus 3y equal to 5. Let us say this point is A, so the point is lying on the line itself, that is A is minus 1 comma 7 by 3. Now let us say there is any point P, so it have been given that the distance of P from the point A is same as its distance from the line. Now it means that point P is lying on the line L2, where L2 is perpendicular to L1, right? Now, if P is lying on this line L2, then we can say that the locus of P is a straight line. So, it does not trace parabola, ellipse or hyperbola. Next is question number 52, which says that suppose a circle with center P touches externally the circle x minus 2 whole square plus y plus 3 whole square equal to 4, and it also touches the line 3x minus 4y plus 5 equal to 0. Then we have to find the locus of point P. Let us say this is the line that have been given, and let us say this is the circle whose center is 2 comma minus 3 and its radius is 2. We have to find locus of center of the circle which is touching this circle and touching the line also. So that circle would be something like this, right? Let us say its center is h comma k, that is P, right? Now we know that PM is equal to R, and let us say this is O and this is Q. So we can say that PQ is equal to PM is equal to radius of the circle, right? Now PM can easily be found because we know the line as 3x minus 4y plus 5 equal to 0. So the distance PM will be equal to modulus of 3h minus 4k plus 5 upon 5. This is PM. Now this is equal to PQ. PQ can be found by finding PO minus OQ. Now PO is equal to, by distance formula, under root of h minus 2 whole square plus k plus 3 whole square minus OQ, that is the radius of the circle, that is 2. Now here it will make two cases because we have modulus, but the question can be made simpler because we know that point P and point O are lying on the same side of the line L1, right? So they are lying on the same side. So we know that by position of points. Now here it can be seen that when I put 2 comma minus 3 in the line, then it is giving me a positive quantity. Hence when I put h comma k in the line, then also it will be positive. So the modulus can be removed very safely. So we get 3h minus 4k plus 5 upon 5 minus 2 can be brought on the left hand side, plus 2 is equal to under root of h minus 2 whole square plus k plus 3 whole square. So taking LCM as 5, we can write 3h minus 4k plus 15 is equal to under root of h minus 2 whole square plus k plus 3 whole square. Now it can be seen that the locus is a parabola whose focus is 2 comma minus 3 and its directrix is 3x minus 4y plus 15 equal to 0. Now from the given options it can be seen that option number C is correct and option number D is also correct, right? I hope the question is clear. Now let's move on to the next question. That is question number 53, which says that let C be a circle with center at the focus of the parabola y square equal to 16x and which touches this parabola. Let us say this is the coordinate axis and this is the parabola y square equal to 16x. Now we have to find a circle whose center is foci, that is 4, 0. Now if the circle is touching the parabola, then they will have a common tangent. Let us say this is the circle. So the tangent on it is this one. Let us say the point is 80 square, 280, where a is 4. So it will be 4t square, 8t. Now, if I join this point with the focus, then we can say that it is perpendicular over here. So, let us say this point is O and this is M. So, slope of OM will be equal to 8t minus 0 upon 4t square minus 4. Also, the slope of the tangent is 1 by t, which means that 8t upon 4t square minus 4 is equal to minus t. Right? So, from here it can be seen that either t is equal to 0 or 8 is equal to minus 4t square plus 4. Now from here we are not getting any real value of t, which means that t is definitely equal to 0. So the point M will be 0, 0. So we can say that the radius of the circle will be equal to 4. Hence the equation of the circle will be x minus 4 whole square plus y square equal to 16. Solving this further, we can write x square plus y square minus 8x equal to 0. So this is the required equation of the circle and there will be a unique circle. So from the given options, we can say that option number A and C are the correct answers. Now we have one more paragraph for question number 54 and 55. It is given over here that suppose Z, Z1 and Z2 are complex numbers and theta is belonging to R, right? So in question number 54, it have been given that modulus of Z minus 3 iota is equal to 4. Then we have to find the maximum or minimum value of modulus Z minus 4 minus 6 iota. Now let us assume we have a circle over here whose center is 0, 3 and its radius is 4, right? So we have to find the distance of Z from 4, 6. Let us say the point is lying here, 4, 6. Let us say it is M and this is P and this is O. Then the maximum distance of point M from the circle will be lying along the line PM and it will be cutting something here like Q. So the maximum value will be equal to QM. Now QM can be found by adding OM in OQ, right? Now OM can directly be found by distance formula, that is under root of 4 minus 0 whole square, that is 16, plus 6 minus 3 whole square, that is 9, plus OQ, that is the radius of the given circle, that is 4. So this is equal to 5 plus 4, that is 9. Hence the maximum value is 9. That is the correct answer is option number B. Now let's find out the minimum value also. The minimum value will be equal to PM, right? That can be found by finding OM minus OP, that is equal to OM is 5 minus OP is the radius, that is 4. So that is equal to 1. So the minimum value is 1. So option number C is also correct. Next is question number 55, which says that if Z1 square plus Z2 square minus 2Z1 Z2 cos theta is equal to 0, then we have to answer the following options. Let us divide the given equation by Z2 square. So we'll get Z1 upon Z2 square plus 1 minus 2 times Z1 upon Z2 cos theta is equal to 0. Now here it can be rewritten as Z1 upon Z2 whole square minus 2 times Z1 upon Z2 cos theta plus 1 equal to 0. That is, from here I can find the value of z1 upon z2 equal to 2 cos theta plus minus under root of discriminant, that is 4 cos square theta minus 4 upon 2. So this is equal to cos theta plus minus iota sin theta. So this is the value of z1 upon z2 that we have got. So from here we can say that the argument of z1 upon z2 is either theta or minus theta. So option number B is satisfying it. Also, option number A is not correct. That is, argument of z1 is not equal to argument of z2. Also, if I take modulus here, then we will get mod of z1 upon z2 equal to 1, which means that mod z1 is equal to mod z2. So from the given options, option number D is also correct. And option number C is incorrect because modulus of z1 plus z2 is not equal to 0, right?